we notice we're not restricted to factoring out just a single term. We can factor out a binomial factor. What does that mean? If we saw x times the quantity x plus 2 plus 3 times the quantity x plus 2, we notice that we can think of that as being the quantity x plus 3 times the quantity x plus 2. We can think of it as though we had a times x plus 2. Oops. We can think of it as being x times a plus 3 times a. We notice we can imagine that x plus 2 as being a, and then we can use distributive property to say that's x, the quantity x plus 3 times a, but then we're just saying a is x plus 2, so we get the same quantity x plus 3 times the quantity x plus 2. So if we saw something like x squared plus 4x plus 3x plus 12, we notice that there isn't an obvious binomial factor, but what we can do is notice that by pulling an x out of the first two terms and pulling a 3 out of the following two terms, we get a common binomial factor of x plus 4. And then we can do that factoring idea. We get the quantity x plus 3 times the quantity x plus 4. And so this is called factoring by grouping. The idea in general for factoring by grouping is to first identify pairs of terms that have common factors, then we factor using greatest common factor. Well, actually it's not always greatest common factor, but we factor by pulling out a common factor. And then we check for binomial factors. So we notice that if we were going to look at 2x squared minus 3x minus, let's make it 6x plus 9, we notice that the first two terms have a common factor of x. So we notice we can write that as x times 2x minus 3, and the second two terms have a common factor of 3. So we could write that as minus 3 times the quantity 2x, let's look at it this way. If we wrote it as plus, we could write it as plus 3 times the quantity negative 2x plus 3, but you notice that they're not quite the same. We have x times 2x minus the quantity 2x minus 3 plus 3 times the quantity negative 2x plus 3. But what we notice is, like I mentioned before, we can always pull out a factor of negative 1. So we can write that as x times 2x minus 3 plus negative 3 times the quantity 2x minus 3. So instead of pulling out a 3, we could have pulled out a negative 3. And so we get x plus negative 3 times 2x minus 3. And if we wanted to, we could also write that as x minus 3, the quantity x minus 3 times the quantity 2x minus 3. So you'll notice we're also sometimes when we pull out a factor of 1, we notice that if we're going to look at something like x squared plus, let's make it x squared minus 3x plus x minus 3, we notice that that's going to be x times the quantity x minus 3, but we notice the only common factor x and negative 3 have is 1, but we can do that. We can write plus 1 times the quantity x minus 3, and so now we have a common binomial factor, x minus 3, so we get the quantity x plus 1 times the quantity x minus 3. So we'll do a couple more examples of that. If we had something like 4x cubed plus 3x squared y plus 4xy squared plus 3y cubed, we have to be careful. We notice that the first two terms have a common factor of x squared. We get x squared times the quantity 4x plus 3y. The second two terms have a common factor of y squared. And so we get y squared times the quantity 4x plus 3y. And so we end up getting the quantity x squared plus y squared times the quantity 4x plus 3y. If we tried 2ab squared minus 6ac plus b squared minus 3c, we notice that we can pull out a common factor of 2a, which leaves behind b squared minus 3ac, minus 3c. And then we can pull out a 1, and we've got that same b squared minus 3c, and so we get the quantity 2a plus 1 times the quantity b squared minus 3c.